Which camera am I looking at? I'm over here. Hey, good evening, everybody. Welcome to Conant Show, and I have a lovely guest with me tonight, Posr.
Posr.
Posr. It is Posr.
It is
okay.
Posr.
All right, and joining me in the discussions tonight, and it should be some interesting stuff to go over. And we're going to kind of revisit an old show of mine where we did showed the demonstration of the alkaline surfactant product that I am representing and marketing and private labeling and all kinds of stuff. I'm a semi-manufacturer, so no, I'm not doing an advertisement or a commercial. This is information only. It's educational. And I am a semi-manufacturer, so I can do this. The idea of this amazing breakthrough technology, which was invented in 1969, folks, that kind of a funny year, isn't it? Out in Chicago by a man by the name of John Flanagan of Bullen Chemical Company, was looking for a water-based degreaser. And he was very deliberately looking for a product that would not only clean the machinery and parts being made. I have to preface this a little bit, folks. In manufacturing, whether you're manufacturing automobiles, sewing machines, it doesn't matter. Absolutely everything if you're working metal, the metal needs to be degreased because it's always being oiled and then worked and then degreased before the next stage. And even if you're not working metals, you have to degrease and clean the machinery that's making whatever it is you are making. So the degreaser, and my father actually gave me this statistic, liquid toxic degreasers comprise 1/3 of the movement of the entire planet's money supply. Okay? Try to. It might even be 2/3, but it's certainly 1/3 of the entire planet's money supply is wrapped up in the manufacture, use, transport, and disposal of liquid toxic degreasers. Trichloroethylene, tetrahydrochloride, and many others, naphtha and toluene. I mean, there's all kinds of stuff. Anyway, to replace these very, very toxic materials was a industrial, a goal. They knew back in the 1920s. This is Colonel Conant talking to me when I was a young lad. And he was saying, if you ever find a water-based degreaser, you get on that elephant and don't get off. Well, as fate would have it, before he died, I got to show it to him, and I blew his mind out there on the farm in Michigan, deep into his retirement. Anyway, so what we can do here is I'm looking for my private label that I'd like to put on screen because I did bring a gallon jug. And but there's this is recycled. You can actually see that this has got the glue from the windshield wash that was in there. But yeah, no, I do recycle.
I want to smell it.
Yeah, it doesn't smell like much. And this is super concentrate. This is industrial level super concentrate, and it's already 95% water. It kind of smells like a wet dog.
And you even accidentally...
But not a dirty wet dog.
It's not oily,
it doesn't smell like there's gasoline in it or some kind of trichloroethylene type degreaser. This is a water-based degreaser. It's 95% water already. The color that you see is a marker dye. This is just to give you an idea of how strong it is. So that you have an idea. If you see any red or pink at all in the product, because you could take this, they take a cap full of this, right? A cap full of this to a gallon of water will give you a nice tabletop degreaser, a very, very effective degreaser for at that concentration.
So there's no toxic chemicals in there.
No, it's actually AAA rated, OSHA and EPA and DEP for non-toxic, biodegradable, 96% in 8 days in contact with the environment, or oxygen and water.
And the cost?
And the cost is, I sell a gallon for I had been.
If you can do that on this show, I don't know.
Well, let me put it this way: it's extremely cost effective, and given that the product is mostly water,
Right.
the chemical components are from common feedstocks, which are in the family of alkali, which is like lye, sodium hydroxide or potassium hydroxide. And then you have variants of ammonia, the halides, and then you have variants of alcohol. So those are the three main building blocks of the molecule itself. The molecule is very interesting. It's a very strange looking molecule, and I actually have a picture of it, and I'm going to put together some slides to put on screen. But while we're doing that, I'll let Posr and you all review a segment from a past show we did right on this table, showing the efficacy of the product. Are we ready to go with that? Yep. What the breakthrough was in 1969, which is kind of an interesting year, and I'll do some that John Flanagan out there in Chicago solved. He solved how to get all three electrical charges into one molecule. And so it has this very unique property, which, as a result, I've made some very remarkable discoveries with how to use it and things that it can do, like freezing oil and water as a homogeneous substance. And, over the course of a very short period of time, that releases hydrogen, and that can be harvested. And then what's left it looked like ash, pure carbon as a very fine particulate. So I have a little jar here, and I'll let Paula come by, and I will demonstrate that I have some spring water in a bottle, and I've been drinking it. Plain water. Now, it will be very, let's see, I'll try to turn it to that side. And if our camera can pick up from that distance the purity of the water there, okay? I have just some Sunoco Ultra Premium Motor Oil, 10W30. Here it is. And I'm going to pour some. It's much more impressive if I have like furniture crude oil. Sometimes people like to use crude oil with a steel wool, and that's how you kind of perk up your finish on some of your tables. That's really impressive because it's nice and black and nasty looking, and it is nasty. And but this is, since this is a very refined oil, it comes out kind of very golden and clear. So it looks kind of like oil and water for for a salad dressing. So are you picking up the separation of oil and water at all? Okay. You should be able to see a fine rind at the top of the water. Yes, that's good. All right, that's great. All right, so what I'm going to do is I'm going to put this top back on the oil here. I'm going to shake the water a little bit, just to see if you can get real close to it. Get real close. Get right on it, as close as you can, because I want you to.
I can't get closer unless I move the camera closer.
All right. Well, that's pretty good. That's good. I'm going to give it again a little shake so you can see the globules. There you go. It looks great. No, this is perfect. I just want to see if I'm not moving in. All right. I'm moving out of the frame. Just want to make sure I'm still in the frame. Very good. All right. So you all can see that there is a separation between the oil, and I'll give it one more good little shake here, and you should be able to see the globules there. There you go. Okay, so imagine Valdez oil spill is something like that. It's the oil is on top of the water, and it floats because it has a lot of hydrogen in it. The hydrogen acts like little balloons, like little helium balloons that hold the carbon chain up off the water. Okay, so what I'm going to do now is take a little bit of this product here. I'll throw it right in front of there so you can see what it looks like. There it is. All right, and this is 98% water. The color that you see is a marker dye so that you can see it. It's colorless. It's fairly odorless unless you put a fragrance in it. And what I would like you to do is get right back on that close-up again, because I want everybody to see. There's that golden yellow oil. There's the clear water underneath it. And I'm going to put a little bit of our product in there, and let's watch the reaction. Okay, now I didn't put a whole lot in there, and I haven't stirred it. Okay, we're just looking at it. Very little bit of product. Now there's actually too much oil in there because it's a proportional thing. It takes apart as much oil. The more water, the better. All right, but for the purposes of this demonstration, I just want to show how it breaks the oil up. And now, in a greater volume of water to oil, like if I had just had a couple of drops of dark oil in here, it would be much more effective to see this transformation, because then this volume of water would be enough to actually absorb every molecule. But when you watch me shake the jar, okay, here we go. I'm just shaking it. Give it a little agitation. People have, actually. So there you have the oil being just sucked up by the water. It's like a sponge. The water is like a sponge, and it's pulling apart those hydrocarbon molecules. And given that this is a highly refined oil, and it's very clean and clear, it's a little harder to break down than if it was crude oil right out of the ground. But it still breaks down quite effectively and quite quickly. And I'm going to take my little remaining bit of water and just test the theory, see, because you can still see, if you get right on there, you should still see the rind of golden oil, brand new petroleum oil, from the bottle here. There's still a little rind at the top. But watch what happens when we simply add more water. And this is what's really remarkable, is the more water you add, the better it works.
So like water's an activator.
And, well, yes, the more water you have, the more room you have to pick up and pick apart those oil molecules. Okay, so that's the tabletop demonstration, and like I said, it's much more interesting and fascinating when you have really good crude oil or something nasty. Now, I've cleaned animals that had gotten into a variety of compounds of engine oil and stuff, and effectively cleaned their fur very, very quickly. All right, so there's a little refresher for you all, and Posr here has got lots of questions because this is the first time that he's seen this phenomenon. And unfortunately, we had to use a previous show. I had some time constraints today to actually set it up. One thing is I couldn't find any engine oil. I got rid of all my old cars, and I've got a not a brand new, but a very new truck that I don't even know what the engine looks like. It's so clean in there, so I couldn't even tap my truck for some oil to do the experiment on the tabletop. But anyway, that does give us a good idea of how water really is the battery for what they call free electrons. And as I was explaining earlier and on the video clip there, the product is made from common feedstocks. Alkali, alcohol, and ammonia are the basic, building materials or feedstock materials for the product. It is a proprietary, and it is more complex than that, but for broad stroke understanding, that's what's involved. If you were to ask me, well, what's in it, I could say, well, we could look at the molecule, and I did a rendering of the molecule from the patents many years ago, and the rendering was looked at by a scientist by the name of Dr. David Summersong, and he goes, "What university did I go to? I did such an excellent rendering."
Do you have the rendering? Do you have it?
And I have the rendering on screen right now. So that's that. Okay, now that's the reaction being rendered. So that, don't go to that one. Go to the previous. Okay, so that's actually from the patents, a rendering of they call it a macromolecule, and it's color coded. So if I remember my color coding correctly, nitrogen is pink, chlorine is green. So you have large nitrogen atoms, and you have small oxygen is blue. Carbon is gray, so I believe that is the entire construction there. So you have mostly pink is nitrogen. So you have nitrogen, oxygen, carbon.
Let me
And a little chlorine.
let me just so oil itself is one of the molecules that compose oil.
All right. Well, it depends on the oil, obviously. But if you're talking like your stuff that comes out of the earth, the mineral, the petroleum oil, it looks like, it kind of looks like, if you were to draw it like a rendering like that, like a centipede.
Not what it looks like, but it's just hydrogen and carbon, right? Basically, that's what oil is.
Well, in a pure state, yeah, because there's always, you're going to have sulfur in there. You're going to have all kinds of I don't want to say contaminants, but other molecules or atoms of other things in there. But they call petroleum. Yeah, that's my label. Yeah.
Very clever.
Yeah, well, yeah, that's my space age. So I have a couple labels, and one's EarthShine, but this is a variant. I'm calling it Formula 51. A very nice, lovely lady friend of mine came up with that, Sabrina Jimenez, down in Queens, and I just thought that was great. Okay, Formula 51 is a little play on Area 51, and my advertising campaign would be a space age product, and it is a space age product. In fact, I want to get it up in space. I want to be the first one to be marketing my product to the. Well, I went to the Russians first because I figured our country was never going to happen, but they didn't get back to me on that.
How long ago was that?
Oh, maybe 15, 20 years ago. I've been working with this product since 1981. 1982.
So it so your product separate or draws the carbon.
How does it work? You're asking.
Yes.
Okay, how does it work? All right. So how the product works is that it makes water wetter. Water is the universal solvent. Everything dissolves in water eventually. All right, and what it does is there are three basic rings. The macromolecule, as I drew it out.
This one?
Yeah, I wish we could.
One before that. Right?
I wish we could really, see it. You know what? I could call it up here so that we can look at it on screen here. I didn't even think of that. So there's three components. There is what they call the combinational ring, the lysing ring, and the attractor ring. The attractor ring is the outside ring in the macromolecule. And what it does is it now your hydrocarbon or your oil is a hydrocarbon, and you're correct. And what you have is you have a chain of carbons, and then you have on all of the available appendages hydrogens. And that's what makes it a viable fuel, because what you're doing is you're picking off the hydrogen, carbon becomes ash, and then the oxygen and the carbon and the oxygen and the hydrogen combine, and that gives you an explosive
Spark
release of energy.
Right. Okay.
And so with our product, kind of the reverse is happening. There's a lot. In fact, there's a lot of associated phenomena with this because the inventor of the product was able to combine 3 electrical charges, or all 3 electrical charges. I believe there's more than 3, negative, neutral, and positive. I believe that electricity is a little slipperier than that. I don't think it's that easily defined. In any event, in this macromolecule of this product,
But what are the
there are all 3 charges.
Other than positive, negative, and neutral, what else?
Quantum stuff, I don't know. It's just from observations I've made over the years that are not explainable. And I'll get into that. So the combinational ring is sort of the ring that is in the center of things.
This
And
one?
yeah, I'm going to pull it up for us to look at, and it is considered something of a benzene ring, except that it's not hydrogen and oxygen that's making the carbon ring. It's nitrogen and carbon, not carbon and oxygen, or carbon and hydrogen. Well, wait a minute, I might not be right on that. You know what? I have to, because I know there's nitrogen involved, there's hydrogen involved too. The hydrogens are the very small ones in the molecule rendering. I may have misspoke on a few things here. And this image there, okay, that we're looking up there, it'll take me a moment to get it on my computer, is sort of a rendering of the interaction of water, hydrocarbon, and the molecule. And yes, it's very nice to do that, because yeah, that was the intention for those 2 images.
So bonds are being broken.
So bonds are being broken, and this is where the science gets really upsetting for people.
Does the water get hot?
No, that's just it. It works. In fact, it works even with you if you subtract heat. You get a whole new set of phenomena involved with it. But with the 3 electrical charges, positive, negative, and neutral, all in one product, you have it's like a free electron battery. And they don't really understand free electrons, because they don't behave in the normal sense of a negative, positive, and neutral. Like I was saying, I believe there is at least a fourth state of electric energy that we don't understand yet.
So there's a fourth behavior.
Yes,
there's a fourth behavior that's happening.
Yes.
That you attribute to a fourth
type of electron. And I'm calling them sliptons, because they're slippery.
They're moving freely.
Yes, they're moving freely. Free electrons sort of really are very hard for any scientist to
But they came from the oil.
pin down.
They came. These sliptrons are coming from the oil, right?
No, they're coming from the molecule itself. And what the molecule does is it energizes the water. That's what it does.
And it makes it orderly?
Well, you're saying it adds heat to the water. When you say energizes the water, you mean it adds heat?
No,
to the
heat is heat, and heat's a form of energy. It energizes the water much like a battery. Well, salt water is a battery. Salt water is what they are used, and saltwater batteries are used in what they call deep cycle batteries. So you can run them for a long time, and you can run them all the way down, and you can bring them all the way back up, but it takes a long time. And they've known about that for a long time. All right, so yeah, okay. I see what's going on here now. This is a little clearer for me. Posr and I are on my screen. We're looking at the molecule by itself, and
Do you want me to put the camera there?
well, no, you just can. Yeah, there you go. We're using just the other one.
The other one.
Yeah, there you go. That one. All right. So this is the combinational ring, basically, and that's
And let the record, let the record,
Combinational ring right here?
yes, that's what he's,
yeah.
yes, that very first ring around the center's
Is the
open space.
that's the combinational ring.
And the two big, the
And
four-
these other lobes here, I couldn't tell you which ones they are, but I am guessing that these smaller appendages have something to do with attracting, and then these other appendages here, the larger ones, which seem to have ring action of their own going on in them. Yeah, there's the bigger lobes, and then there's these two tinier ones that are on the right that come off. I believe I'm guessing, like I said, because I don't have.
Okay,
This was
you see the one that, yes, that one. That one is that's one of the, now which is that?
I
That-
think this
the
is
one- This one is,
these I think are the attractors.
right, so that.
They're attracting.
Okay, we have to do this like a court thing so that the people can see what you're
Yeah.
referring to.
Right.
And what you're referring to. If
Yeah.
you go back to the,
Image.
image, no, go
Yeah.
all the way to the image, all the way to
There
the
you
image.
go.
Okay,
Okay.
you see that thing that's going down as if it was like a flaccid penis?
Yeah.
Okay,
Now
that,
we know where we are.
yes, now that one, you believe is a attracting.
I'm guessing. Guessing. Because I don't know. This was, I literally drew this, from the patents, which you can't have access to anymore, and it's a good thing that they don't, because then, people just knock it off. But the idea is that on the outside of the whole structure it attracts, and then you have a structure that holds it together. And then while it's held together and the hydrocarbons are being attracted, there's other aspects that are like a buzzsaw and pick off the hydrogens and the carbons by satisfying the needs. That's funny language, but satisfying the needs of those atoms.
So let me get this straight. This molecule, you're saying, is attracting the oil, the hydrocarbon. It's
Attracting the hydrocarbons.
like
yeah.
a magnet,
Yeah.
basically.
And it says, "Come get me." It's very attractive.
And okay.
And then
And in that attraction, bonds in the oil itself are broken.
right. So if we were to go to the other image, there you go. On the in the cluster in the upper right quadrant, sort of representative of. I'm trying to remember how I was setting this up. All right, so that is like water, and water has a lot of different things in it. You have these very small individual blue they look like Mickey Mouse, like the blue atom or circle has two pink or reddish atoms on either side of it. That's H2O. That would be two hydrogen and one oxygen, and that's like a water.
Yeah, that's one of them.
Atom,
that
right?
you're on now, Paula. That's one.
Right. So that's an individual water, and then you would have like some free moving around, some carbon that's been released from the reaction between the molecule and the soap molecule, between the soap or the detergent and the hydrocarbon. So, for example, if you go to the lower left-hand quadrant, you'll see the benzene rings. This is hydrocarbons. This is a form of hydrocarbon, and that would be like a benzene kind of, or gasoline kind of a structure.
In the lower
And
left.
then on the lower left.
Yes.
And then if you were to go to the upper left, this is a chlorinated biphenyl.
Well,
So this is like a
yes, that bullet-like thing that you were just on.
it almost looks like a
Yes,
yeah, that almost looks like like I said, like a centipede. Okay, that's another hydrocarbon that's based on petroleum, much like the benzene ring in the lower part of that same half of the page. All the blue represents oxygen, so that's oxygen, and the oxygen that becomes available, say, from the air or the environment, also comes into play into the reaction. But as you start picking apart the different elements, you know, because carbon is an element, oxygen is an element, then the interaction becomes more and more mixed. So you end up getting something that looks like what's going on the far right of the page, or the far right.
At the
Above
bottom?
oxygen.
Above the oxygen. So what you're seeing is that this funny little molecule here has this property of being
This
able
one?
to integrate as
Yes,
a
that.
homogeneous substance, especially towards that right, sort of lower right side, just above the blue, all the blue.
You say the molecule, rather the oil is integrating itself into the molecule?
Well, it's beyond that. What's happening is this like this benzene structure
On the lower left, yeah.
in the lower left, or the and that's a
Caterpillar.
chlorinated biphenyl. Okay, so that's like a PCB, right? Looks something like that. You have a chlorine attached in the mix with these carbons and hydrogens, right? What happens is they get picked off, and as they get picked off, they get attached to water. So the molecule just keeps attaching the carbon and hydrogen to oxygen, and you're getting more water, and then other elements, like in this area up here, start getting freed up. The carbon becomes freed up, and it becomes available to.
So it's rearranging the molecules of the oil into some other compound.
Well, it's beyond that. It's actually taking the oil apart. It's just taking it apart, and new compounds would be available to make out of it if you knew what to do with it. I call it cold cracking. So you can if you add aluminum bisulfate into that mix of say, let's take an oil spill like Valdez, and you got all that crude off the ocean water, and salt water, by the way, doesn't impact the efficacy of the product at all. In fact, it kind of enhances it. Seawater is on the alkaline side of things, and it does make the product work better in this scenario. So if you take that crude and you homogenize it with a volume of water, so that it's no longer crude oil and it's no longer soapy water, but one completely homogeneous mix, and you add aluminum bisulfate to it, it will separate out, and you will get a petroleum product at the top, water and free electron product in the water, and then you'll get a carbon and you'll get a fallout of particulates, whether there's sulfur in there or whatever else might
But
be.
then you would still have water on the top of the water. If you get an oil product, you still have water on top of the water.
No, well, no. Water is below the oil, because the oil at that point is recombined with the hydrogen. The carbons and the hydrogens are recombining into a oil again. When you can reverse this by changing the chemistry by adding into that mix aluminum bisulfate. And this is from the manufacturer found this out.
Well, but this new
So what I'm-
compound, you're saying is a petroleum compound.
Well, yeah, it is, because that's where we started. But it's not the same anymore, because any impurities, that's the word I was looking for, folks, impurities. Whenever you mine anything out of the earth, and it doesn't matter whether it's coal, diamonds, petroleum,
Okay.
it has impurities in it. Sulfur is one of them. There was a big deal about getting sulfur out of our fuels about 20 years ago, if you remember, because of acid rain, right? In any event, there are ways of chemically altering the petroleum to get all different kinds of, like I said, I call it cold cracking. When you're refining petroleum, it comes out of the earth as a goo. All right, it's a thick.
Yeah.
It smells bad. I mean, it's some nasty stuff. Sticky. Some of it's what they call light crude is already very pure and clean-ish, like what comes out of Saudi Arabia is a light crude. It's very valuable because it's easy to manipulate. But the heavier crudes, the tar sands and things like that, they have a lot of polymers in them, which are useful for other things like making plastics. So from petroleum, you get all of your plastic products, your clear wraps, your body panels on cars, to these chairs over here. That's all. This is all these synthetic materials are ultimately a mineral product called petroleum. What this stuff can do is, in the history of making diesel, or what do you call that, kerosene, that was the replacement oil for whale oil. In the 1880s, whales were just about extinct from the whaling, because that was fueling our world for oil lamps and heating oil and such like that.
So the value of the product is more in refining the oil than it is to clean up an oil.
Oh, no. It's the value is for cleaning. It is primarily a cleaner, and what it does is, I'm just explaining how you can manipulate when it's in that homogeneous state before it has completely broken down and disappeared on you, because that's what will happen. I've cleaned up many different sites. Some of them on a macro scale, where you have a water table in an Indian reservation that's been contaminated.
When you say you've cleaned up sites,
Yeah.
the oil is still there. Well, oil, some petroleum product is still there.
No. Gone. Completely gone. What happens is the once I'm talking about a method of recombining it.
Okay, yes.
All right.
You
But that's just something that you can do chemically, working with the free electrons. Okay? But in the process, if I were to do this to purify a site, I don't want to recombine anything. I want to, unless, see, there's the other thing there's a couple of spurs here that we can talk about. There's a thing called oil recovery, and that's what I was actually kind of telling you about, is a method of oil recovery. It's like, we don't just want to like destroy all this stuff and take that Valdez spill oil and just homogenize it and turn it into fertilizer, because that's what you'll do. What it'll do is it'll become available molecules, and in that non-toxic state, it's just kind of like this. You're going from hydrocarbons to carbohydrates. You're going from petroleum oil to bread, literally, but on a chemical level.
So this is converting oil into carbohydrates?
Mm-hmm. On one level. There's a lot, because there's a lot going on here. It's not much understood.
So basically you could eat it.
Yeah.
Afterwards.
Mm-hmm.
So actually the molecules of the oil are being recombined.
No, the oil. Well, the molecules of the oil are being taken apart, so they're no longer oil molecules. Molecules are
Right.
not atoms. So
Right.
now you just have atoms of raw materials. Now you just have carbon,
Carbon,
hydrogen, oxygen, nitrogen,
Just freely floating around.
just in the mix, freely floating around because they are not bound to each other. They are not bonded. It's like law language. It really is because we're talking about universal law, in a way, really, when it comes down to it. And this molecule is really remarkable because it's very similar to blood. It's very similar to a living molecule such as blood, such as hemoglobin. And that's a really unique thing because it has a strange, unique property of knowing not to harm living tissue, but at the same time, it's a hospital-grade disinfectant. It knows what to take down and it knows what not to hurt. And that's where I believe that in this free electron molecule, there is a quality of consciousness to it. And
You have to use it to believe it.
yeah, I mean,
Well, I left my engine cap off, so I have like a lot of oil on top of the engine, right on top right now. So,
Yeah.
So afterwards, maybe you can give me a little demonstration.
sure.
Yeah.
That's a perfect demonstration. I wish I had my camera with me. I would have
Well,
I would have videotaped that.
We can do it on the phone.
Yeah, we could do that. So
Just gonna cut it. Okay.
so the further the thought,
Well, but you lose. I mean, then in an oil spill, and I don't know. I think we may, as a planet, we may be coming away from oil. But for the moment, if you're breaking up all the compounds into their individual components,
into the elements,
into the elements,
right?
you're losing the oil.
Correct. And here's the thing about freezing that one of my earliest discoveries was in the early 1980s. I was using this for all of my automotive products because I through a set of really unique circumstances, I was introduced to the product through an open house that this man who just recently died, a good friend of mine many years, and think tanker and business associate with he was the one who introduced me to the chemistry, to the product. And I had just seen my dad about 3 years before that and had that conversation about industry was looking for non-toxic water-based degreaser because it represents the world's single largest market. And it is two-thirds. Two-thirds, not one-third. It's two-thirds of the planet's entire money supply is wrapped up in the
Degreaser.
making, the manufacturing, using, and disposing of liquid toxic degreasers. And the reason why it's such a massive amount of our entire money supply is because everything everywhere needs to be cleaned. Everything everywhere. All machinery in every factory everywhere has to be degreased. So these guys are moving and using millions of metric tons a day on the planet of this one style of product, just these liquid degreasers.
Are these toxic liquid degreasers more expensive or less expensive?
Much more expensive. Much more expensive than...
So then, if you approach a particular manufacturer, it's slower than approaching a whole company, but eventually, a particular.
Oh, it's out there. It's a Fortune. My parent company is a Fortune 500 company, and they grew hugely because of our advertising.
So people are already buying.
Oh, it's used in the industry, but it's completely underutilized technology. It's been a real hard battle because a lot of industries that are in the business of containing and moving toxic materials, they don't want the
Right,
toxic
of course
material to
not.
disappear. They're making a
want
lot
it.
of money. The skimmer boats and all of that. Now it would be great for them.
A skimmer boat.
Yeah, with the boats that go out there and they skim the oil.
Okay, I'm not familiar with that.
Right, and then they have these mats and then they have these, and then they soak up the oil from the environment as best they can in these
Mhm.
mats, and then the mats become something that you have to store and get rid of and deal
Right,
with, and it
right.
costs a whole lot of money, and the persons or companies that are employing the companies that do the cleanup have to pay out for the cleanup service. See, so there's a tremendous amount of money in moving toxic materials and storing them. They don't want them to disappear.
These degreasers.
They do not want these materials to disappear, because if they did, as one guy in Long Island I had a business meeting with, he says, "You're going to put me out of business. I don't want your product. You're going to put me out." Yeah. So this is the kind of thing you end up with. So when you do these demonstrations, you bump up against the lag between real world use and practicality and
Survive.
the future, you know, of a specific technology. So the future is water-based, but to get from
Oil-based to water.
oil-based consciousness into a water-based consciousness, because they're so entrenched. No. For example, you know, we had a team go up to Valdez, and they were in Mars Cove, and you know, I keep forgetting that was a long time ago. So for a lot of folks, you don't even know what Valdez means. It was one of the largest oil spills in the Alaskan Gulf of Valdez, in the Aleutian Islands. It was a disaster of unprecedented size and scale, and it was also a weapon. And
Not to cut you, but so when there is an oil spill, are there like bids?
He's telling you the story.
yes,
You know,
oh yeah.
there are actual bids on who's going to clean it up.
Well, it's even better than that. The Valdez spill was spooky, because when we went up there with our guys right to the beaches, we started experimenting on the rocks and on the water, and just to see what was happening, and it was working quite well, actually. It was very, very impressive things were happening up there. A squad of black post-World War III uniformed Uzi carrying guys came up and chased us off the beach saying, "This is Exxon spill, get your stuff out of here. You're not allowed to touch our spill, it's our spill."
So who got that contract to clean up that spill? Do you have you know?
I don't believe that they actually did a cleanup. There's still a lot of stuff around that Valdez experience that's unresolved. But what they did do is they contaminated the Kodiak Islands to such an extent that the native people who had the rights to the territory for their pristine, and it was called a pristine wilderness area, which was also part of the treaty territories of the Inuit and other tribal groups, and that's why it was it was off limits to offshore drilling. After the Valdez spill, it was considered a contaminated zone, and offshore drilling was just fine. And that's what they did. They made more in the offshore drilling than in any of the fines, which much of the fines they didn't pay even. This is Exxon. That's the real thing that we learned.
So then there's a possibility that the Valdez could have happened just to get the offshore drilling there.
That is our presumption, and we are acting on other information that had come to us through quasi-military sources that was the case. But anyway, what I was trying to get to is that the oil on top of the surface of the ocean does a thing called asphaltizing. It starts to cake up. It gets hard, and it's cold temperatures and cold water. So that also contributes to the
Caking effect.
the solidity of it. When and the skimmers come along, and you're trying to skim the oil off the ocean and get it back into a boat. That's the idea. Well, you can't. This stuff doesn't move. So they were hitting it with steam. So as they were skim up a bunch, they would hit it with steam and try to loosen it up that way and skim it that way. Very ineffective, very hard, very difficult procedure. And I was on the phone with the commander of the fleet, of the Coast Guard, that was on point up there from his ship. I got through to him from a phone in Connecticut. And I told him what I had and what it could do, and that it was non-toxic, AAA rated OSHA for, you know, non-toxic to the environment or animals or humans or anything like that. And, you know, would a product like this help you? And it loves steam, by the way. So it works great in heat. More heat, the better.
Right.
And he was like, that's exactly what I
What
need.
about in cold?
And let me get back to you, and we'll see if we can get, you know, some of this stuff shipped up to us.
Oh, you were saying that they could that they were doing steam anyway.
Right, just
So
just
put the-
inject it into
right,
their
right,
steam
right,
equipment,
right.
and they would
Right.
be
They'd be
off and
yeah,
running
Yeah.
in a very optimum
Did
way.
he ever get back to you?
He got back to me in less than 8 hours, and he says, I don't know what you got. We really do want it. We did our research and due diligence. We know it's real. The problem is somebody very, very high up doesn't want us using it. I'm really sorry about that because we really need it. And that's coming from the commander on site, from the ship, on phone. So we know from many, many experiences like this that there is a vested interest in keeping the poison poisonous. Because with this technology, there is absolutely no reason to have anything toxic anymore.
But so it wouldn't be I mean, I wouldn't imagine it would be the petroleum companies themselves, because once it's spilled, what interest do they have in moving toxic cleaners or you know, like,
They don't.
right.
It's
So
all
I'm
the-
saying it's not the
But
petroleum.
but you know, when you get it to this level of corporations, the petroleum corporations, the big pharmaceutical corporations, the big Google, I mean all the really big corporations, the transnational corporations, big agribusiness, the fertilizer people, the you know, synthetic drugs, the pharmaceuticals, and petroleum, they all have the same boards of directors sitting on their boards at a certain level. When you get way up in that realm, it's the same cast of characters frequently, not always, but a lot of the time. So you're dealing with, you know, subsidiaries of the big companies and subsidiaries of the subsidiaries that are out there doing the in the field work. And then you get down to the grunt guys. They don't even know who they're really being paid by at the end of the day. You know, who really is the boss? Is it your boss, or does your boss have a boss? How far up the food chain does it go? That's kind of what I'm seeing is the layout. It's a pyramid.
So this just goes back to my our cleanups bid for.
Yes,
They're bid
there are
for-
companies out there. There are competing
But
companies.
they're not bid to the government. They bid to the private company that spilled it, or are they bid? I mean, is this a government-controlled?
It's very weird, and I think that there is, to some extent, government oversight, but the government can't. Like when I brought it to the Department of Environmental Protection, and when I brought it to the EPA, and when I brought it to Environment Canada, I got the same story from their top scientists. Love your program, yeah, it will work, but we can't advocate for it. We can't put you into anybody. We can't use it ourselves because we're regulatory. We're not in the field. So you have to soft sell it or sell it, hard sell it, soft sell it to the corporation, target corporation that's in the field on the project that you want to deal with. Kind of like that.
It's probably so largely it's so largely unknown that. What about environmental groups? Have you?
I was getting to that. What happened up at Valdez is the guys who went up. I didn't go up, but we had a crew go up in a big truck, and we sent up probably 200 or 300 cases of raw materials, not super
finished
concentrate, but actually the raw materials, and you mix it on site so that we can
Okay.
bring. We were prepared to bring to the table quite a bit of product up there, and we did. And we started experimenting, not experimenting, because by this point we knew what we were doing, cleaning the crude oil off of seals and cormorants and everything else up that there's a place called Mars Cove, and they were using the state-of-the-art cleaner was Dawn dish detergent. So they were using Dawn dish detergent to wash the animals, and not really getting very far. Our stuff comes along, and the animals are being degreased in seconds. They're being degreased in seconds, and they freaked out so bad they literally chased us out of there. So we
Well,
got chased off the beach by Uzi carrying squads.
You have to come with your own armed squad. I'm serious, though. I'm not saying that just facetiously.
Yeah,
You
no.
have to actually come with an armed group, because you have a right to be on the beach, right? I mean, it's the beach. It's the public beach.
Well, I don't know. I wasn't there. I mean,
It's just beach.
but it's the spill. It's their spill.
Ah, the spill. Well.
They
no,
own
no,
the spill.
no.
Yeah, that's what they said to us. This is our spill. Get out of
They
here.
own the oil that's spilled.
Yeah.
Wow.
But they don't own the beach
Beach.
that the spill is on.
But they don't want us messing with their spill.
Yeah, but they don't have a right to say that you can't go on a public beach.
Well, you know what? We're not going to argue with an Uzi.
But that's why I'm saying you actually need an armed.
All right.
I'm serious. You actually need an armed security
Team.
detail.
Yeah.
Because they're not going to
Yeah.
see. They'll come with you. You don't
Yeah.
have any weapons.
We'd have to do another show because I've been
Yeah.
bugged, I've been tailed, I've been monitored. This product I've cleaned up major spills on oil on
Yeah.
Indian reservations to
Yeah.
the satisfaction of the EPA and the local communities that were negatively impacted by the spills. I've dealt with the Dr. Ward Stone, who was New York State's chief wildlife pathologist for many decades as a result of this work, and I can share many stories of just how dangerous this is, just for having something that works.
Yeah.
But we got to go.
We gotta
That
go.
was a quick hour, folks.
Yeah, that was
So
great.
thanks for watching Conant Show, Posr again.
Oh.
We'll have to come and continue the
Yeah,
discussion
yeah.
because it's a worthy discussion,
Yeah.
and we'll do a better demonstration. I'll try to get a hold of some real heavy crude, and we'll do it on the table again. There's my little label. All right, folks. Thank you, Paula Gloria, for teching, and thanks, Bill McKenna, for getting good cameras. I'm going to keep remembering you because, well, they're better. Hey, you know what? They're better than they were. Let's go there. All right, and I'm trying to keep it positive. And what else? Today's date. We got to date it. Date is 25 September 2019. All right, everybody, over and out.